Hi everyone, this is lesson 2.6, writing ratios and proportions. In this lesson, you're going to learn how to write a ratio to represent a real-world equivalence and solve simple proportion. This lesson is important because in tomorrow's lesson, we're going to learn how to set up more complicated proportions and solve for missing variables. Also in this video, I am accompanied by my dog Penny. Oh, I just scared her. So you might hear her chewing on her bone, barking, or whatever other noises dogs make. So without further ado, first to learn about proportions, we have to learn about a ratio. So a ratio uses let's talk about the difference between a ratio and a proportion. So they are two related terms, but a proportion is actually an equation of ratios. So a ratio is actually just a fraction, for example, a over b, and a proportion is an equation of two ratios. So one ratio equals another ratio. So a proportion is an equation, where a ratio is just a term or a fraction. So anyways, a ratio uses division, hence the fraction, to compare two quantities, and you can write it in three different ways. So the first example would be a over b, and the second way would be a colon b, and then a third way it would just be to say a to b. Sorry, this is supposed to be an a. So each ratio is read the ratio of a to b. Ratios should be written in simplest form, so always reduce your fractions. And in a ratio, it's okay to have an improper fraction. Improper fractions are totally fine. Also, don't forget to use your fraction button. So I'm going to pull up my calculator just to show you the different ways, remind you of the different ways that you can write or make a fraction in your calculator. While that's loading, let's go ahead and look at our first example. So number 1, a volleyball team plays 14 home matches and 10 away matches. Find the ratio of home matches to away matches. So whatever is in front of the 2, yeah, there's a 2 right here, whatever is in front of it goes in the numerator. So the home matches are going to go in the numerator. 2 away matches, so away matches will go in the denominator. Okay, so that would be home is 14, away is 10, and then that reduces to 7/5. So let's say that you had a more complicated fraction and you didn't know how to reduce it. So let's go ahead and get out your calculator, and let me show you a couple tricks. So one way, if you have a newer calculator that says TI-84 plus CE, or if it has just the plus or the CE, you can press second and then y equals, oh, I did not press the right button. Sorry, alpha, not second. Alpha y equals, and then this first option here is the fraction button. Okay, so let's practice. 14 over 10, and it'll give you, if you press enter, it'll give you the reduced fraction, 7/5. Okay, here's another way that I think works on this calculator. If you do alpha and the button right next to it, alpha x, it pops up the fraction right away. So then you can type 14 over 10. Okay, so let's say that, that's not 14 over 10. Anyways, we figured out what 14 over 110 is equal to. So let's say you have an older calculator. Here's what you can use. You're going to press math. You might want to write this down so you remember. Actually, hold on, go back. Type in the original fraction, so 14 divided by 7. You'll have to use the division sign for your fraction bar. And then don't press enter. Instead, press math. And then this option says convert to a fraction. So it'll convert it to a reduced fraction. And then enter one more time. And then it says 7/5. Okay, so those are 3 different ways you can get a fraction button in your calculator. Alpha y equals, alpha in the x button, or type in the fraction with a division symbol, and then press math, fraction, and enter. Now you could also do that like if you have a decimal, so 0.2, if you wanted to convert a decimal to a fraction, you would go math, convert to fraction, and then it gives you a decimal 1/5. All right, so anyways, part B, the ratio of home matches to away all matches. Okay, so home to all would be 14, and then all would be both of them, so 24. And then reduced, that would be 7/12. Okay, so pretty easy, right? Let's just do this one just in case. Derek and his brother decide to combine their CD collections. Derek has 44 CDs and his brother has 52. Find the ratio of the number of Derek's CDs to the number of his brothers. So Derek's to his brother would be 44 over 52. And let's see, both of those numbers can be reduced by 4. So it'll be 11 over 13. And then the ratio of the number of Derek's CDs to the number of the entire collection would be 44 over 96, which reduces to well, let's check our calculator. I have something written down on my paper, but I can't tell exactly what one of the numbers is. But this would be a good time to check with our calculator. So I'm going to do it the old way. I'm just going to do 44 over 96, click math, fraction, enter, 11 over 24. Okay, that's what I thought. Always good to double check. So this is 11 over 24. All right, so next, let's talk about proportions. So like we were mentioning earlier, proportion is an equation that states that 2 ratios are equivalent. For example, A over B equals C over D. So it's an equation. If you have an equation, then you can solve. So we're going to learn how to solve for x. One of the numbers in the proportion is unknown. Okay, so that's what we just said. So now let's solve very simple proportions. So the way you want to do the proportion is figure out where your variable is, and then if it's in the numerator, then you're all set. So for these, all of our variables, notice, are in the numerator. So what you want to do then is take your denominator, and since it's kind of like x divided by 30, to get it onto the other side, you want to do the opposite, so multiply by 30. And I like to think about it as like multiplying by 30 over 1. So that way, if this is a fraction, I'm multiplying it by another fraction. Okay, so the 30s cancel and you get x equals. Now you can do multiply across, but one trick you might want to do is to cross reduce. So here you can cross reduce 30 with 6, would go 1 and 5, because 30 divided by 6 is 5. And then you have 5 times 11. You don't have any negative signs here, so we're all good, which would be 55. For number 2, you want to multiply, do the same thing, but multiply by 35 over 1. So then the 35s cancel, you get W equals, now look at this, good news, 7 and 35 go into each other. So each of them divide by 7, so 7 divided by 7 is 1, 35 divided by 7 is 5, and you're left with 4 times 5, which is 20. Right, so I'm going to pause the video, or well, you will be paused and you will get to try numbers 3 and 4 yourself. All right, so if you didn't get the answer correct, here's how you would do it. So here you multiply both sides by 12 over 1, just like in the last two examples. And then 12 and 2 reduce to 1 and 6, or 6 and 1. And then 6 times 9 would be, 54? So 54 equals m because the 12s cancel over here. All right, on this side, you multiply by 54 over 1. Okay, so 9 and 54, we just work with that problem over here. It would be 1 and 6. So then 5 times 6 would be 30. That's how you do those two problems. All right, so let's, all we have to do next are 3 examples then. So we're going to do some examples with setting up proportions in real-world situations. So first, the first one is a recipe. So recipe for tomato salsa calls for 30 tomatoes to make 12 pints of salsa. How many tomatoes are needed for 4 pints of salsa? Set up a proportion to solve. All right, so it says it's 30 tomatoes to 12 pints of salsa. So let's convert that into a ratio. So tomatoes to salsa. Tomatoes will go on top, salsa will go on the bottom. Also, when you set up a proportion, it's good to label your numbers. So don't just put 30, put 30 tomatoes over 12 pints. That way, when you get to your final answer, you'll remember what the units were, and you can make sure that your units match up. And then the other part of our proportion should have the same. So it should have tomatoes on top, pints on bottom. You can flip it, so you can put pints on the top and tomatoes on the bottom, but you have to do it for both sides of the equation. So here we're asking how many tomatoes. So let's use x. So x tomatoes. Sorry, that's my dog chewing on her bone, in case you didn't hear that at the beginning, but I can't stop her. She's just munching over there. If you can hear that, sorry. Over 4 pints. Okay, so just like in the last examples, we'll take the 4 and multiply it on both sides as 4 over 1. 4 and 12 reduce to 1 and 3. And then 30, now we have 30 divided by 3, which is 10. Also, what you can do is include the units. So pints and pints, 4 pints. And then notice that units can actually cancel like numbers. So this pints will cancel with this pints in the denominator. Pints in the numerator, pints in the denominator. So 30 tomatoes divided by 3, no units left, would be 10 tomatoes equals x. Also, when you do this, the 4 pints also divides from the 4 pints. Okay, so 10 tomatoes is our final answer. Okay, and make sure you get used to understanding how to set up a proportion, because the problems will not just ask you for the answer, it'll ask you to set up a proportion or possibly select the correct proportion that would represent the problem. Number 2, the elevator that takes passengers from the lobby of the John Hancock Center in Chicago to the observation level travels 150 feet in 5 seconds. So 150 in 5 seconds. Let's set up a ratio for that. So 150 feet over 5 seconds. The observation level is located on the 94th floor at 1,029 feet above the ground. Find the time it takes the elevator to travel from the lobby to the observation level. So this would be equal to the feet over time. So 1,029 feet over x seconds. All right, so we have a problem here. So the problem is that x is in the denominator, and we don't want x to be in the denominator when we solve. Notice how all the other questions, the x was always in the numerator. So the easy fix is actually to just reverse our fractions. So instead, I'm just going to erase this, actually. I'm going to put 5 seconds in the numerator, and then the 150 feet in the denominator. Then I can rewrite the other side as x seconds over 1,029 feet. So x seconds over 1,029 feet. Okay, so now we can go ahead and work with the problem. So just like in all the other examples, we will multiply both sides by 1,029. You put it over 1 if you'd like. Now, not really sure what this is off the top of my head. I know that 5 and 15 can reduce to 1 and 3. So then the problem becomes 1,029 divided by 3. Also, if you include the units, feet and feet are going to cancel, and you're going to be left with seconds, which is what we're trying to find. So let's take our calculator and divide 1,029 by 3. So 1,029 divided by 3. And I'm feeling like it's going to be okay to put a decimal in this example because we're talking about seconds. 343 seconds. Actually, guys, I think I did something wrong. Let's see. There's a 0 here, not just 15. So this is supposed to be 30. Okay. So back to the drawing board. 1,029 divided by 30, not 3. Which actually you can do it in your calculator, but it just moves the decimal point over. So it's going to be 34.3. All right. So 34.3 seconds. Okay. And then for the last question, when 2 full moons appear in the same month, the second full moon is called a blue moon. On average, 2 blue moons occur every 5 years. Find the number of blue moons that are likely to occur in the next 25 years. All right, so we'll put blue moons for every 5 years. So 2, you can just say moons over 5 years equals x moons in 25 years. Okay, so now I'm going to show you a different method that some of you might have been thinking of already in your head, but that is the fact that, well, when you look across here, if 2 moons are for 5 years, how many moons would be for 25 years? Well, 25 is 5 times 2, or 5 times 5. So to get the number of moons, wouldn't you just take 2 moons and multiply by 5? Yes, that can work. So if your problem works out like this, then you can actually solve it that way. It's not always going to work. We'll see examples tomorrow where, in the next lesson rather, where you won't be able to do this. Okay, the numbers will be more complicated than that. But for these simpler examples, yes, you can solve it like that. So the answer is 10 moons. All right, that is our last example of this lesson. Tomorrow you will do the Elastic assignment. So have a great day.